Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are two of our students who I will let introduce themselves, starting with Eli.
Hi, I'm Eli. I'm a physics and astronomy student here at UMD.
Hello, I'm Braden, and I'm a music education student here at UMD.
Awesome. So, tonight's show was one that was actually requested a few months ago, where we're going to be taking kind of an in-depth look at Jupiter and its moons. And this kind of came about, I think it was in our exploring, one of our tour of the moons of the solar system show. And someone wanted to talk more about all of the other moons of Jupiter. And so I figured it could be a really fun show to just talk in depth about it. And that's part of what we do with this exploration series. Sorry, I don't have the stream pulled up on my phone, so I can't see comments. There we go. Okay. So we are going to get going with that. Give me just a second to get everything set up. Let's go ahead and pin me there. And we come over here. Let me do that. Trying a slightly different setup today to see if this helps me. It's not going to be too different on your end, but I'm just trying something a little new. Okay. There we go. Yes, so as I said, we are looking at Jupiter and its moons tonight. Now, as always, for all of our shows, if you have any questions, you can leave them down in the comments. Eli and possibly Braden, I don't know if you have it up as well, but they will be looking out for questions in the comments. Will let me know when those come up. Keep in mind, there is a little bit of a delay. So if we don't get to your question right away, we will make sure to answer questions at the end of the show as well, so we get to all of them. All right, so starting off our kind of exploration of Jupiter and its moons, we're going to start with Jupiter itself. And Jupiter is one of the 5 planets that we can see with our naked eye from here on Earth, the others being Mercury, Venus, Mars, and Saturn. And since Jupiter is one of those planets that we can see without a telescope, it has been known since ancient times. People saw that point of light in the sky, saw it slowly move with respect to the other stars, and so they knew it was there. And most of the time, the planets that were seen, because they moved differently than the stars, they were usually associated with gods. And for some reason, Jupiter itself was usually associated with kind of the leader of the group of gods for that culture, assuming the culture was, polytheistic. But it was usually that sort of thing. So let me stop rambling and get some pictures here. So on the left here, we have the Babylonian representation. This is Marduk, who is, again, the chief of their pantheon. Then to the Greeks, this was associated with Zeus, of course, king of the Greek gods. The Roman equivalent of that is Jupiter, which we can see on the far right. And so all of these were associated with this planet. The day Thursday is actually also named after this planet. All of the days of the week are named after the 5 planets, the sun and the moon. So Thursday is Thor's day, and Thor is the equivalent of Zeus. So that's where that comes from. One thing that I learned while doing my research for this talk, for the show tonight, was that in Chinese culture, the 12-year zodiac cycle that they go through is actually based off of Jupiter, because Jupiter takes about 12 years to orbit the sun. They used that number 12 and based their kind of zodiac off of that 12-year cycle, with each sign in their zodiac corresponding to a year, and then you take 12 years to go through the full cycle. And I just thought that was really cool. And Eli was telling me earlier that that's a pretty common thing in um, Eastern cultures,
Kind of all over the place. You see
kind
it
of all
in
over.
yeah, Maya, like astronomical calendars and stuff too.
So yeah, the number 12 usually came about because of orbit of Jupiter, and the number 20 was often used because of the orbit of Saturn. It's really cool. I definitely need to delve more into the ethno and archaeoastronomy. Like, there's so much more there that I just haven't learned yet. Okay, moving on to a little bit more recent, still, past to us, but one of the, I guess, first notable kind of observations of Jupiter came about in the early 1600s thanks to Galileo Galilei. He was, if not the first, one of the first people to look at the night sky with a telescope, and is credited with being, the first person to observe the planets through the telescope. And when he was observing Jupiter, he actually found these 4 little points of light that orbit around, and he concluded that they were moons. This was the first discovery of moons around another planetary body, around something else. And so these 4 moons are the 4 largest moons of Jupiter, now called the Galilean Moons after him. And this was actually really significant because when Galileo was making these observations, there was a really big kind of debate going around between whether our universe at the time, but solar system, was either geocentric, meaning the Earth was the center and everything orbited around it, or if it was heliocentric, the sun was the center and Earth was just another planet with the other planets that orbited around the sun. And this observation by Galileo showed for the first time that Earth was not the only center of motion out there, that there were other things like Jupiter that had other things orbiting around it. So it wasn't just Earth that was special or the only one doing that. And that helped lend even more evidence for that heliocentric, which of course is what it actually is. But Galileo was very, very crucial in finding the kind of like last nails in the coffin to prove that heliocentric was the correct model. All right, so let's get into some basic properties of Jupiter. So Jupiter is further away from the sun than we are. It sits a little over 5 AU from the sun. An AU is an astronomical unit. 1 AU is essentially the average distance between the Earth and the sun. So what we're saying is Jupiter is a little bit more than 5 times further from the sun than Earth is, which in kilometers puts it at about 778 million kilometers from the sun. And as I've already said earlier, at this distance, it takes about 12 years for Jupiter to orbit the sun once. So a Jupiter year is about 12 Earth years. So Jupiter is the largest planet in our solar system. You can see here a couple of size comparisons. So Jupiter is a little bit under 11 times the diameter of Earth and a little over 300 times its mass. Now, compared to the sun, Jupiter is still pretty tiny. It's about 1/10 the diameter of the sun, and I think it's like 1/1000th the mass of the sun. But Jupiter is by and far the largest planet in the solar system. It rotates pretty quickly. It actually completes one rotation in about 9 hours and 55 minutes. So it rotates a lot faster than Earth does. Now, of course, the part of Jupiter that we see is its atmosphere. And I have to tell you, I had to cut so many slides that were just look at these gorgeous pictures because I figured you don't want to be here for an hour. But I'm telling you, the Juno spacecraft has taken some of the most stunning pictures of Jupiter. And if you are interested, you should just go Google Juno spacecraft, Jupiter, something like that, and you will get just, oh, beautiful. This is one of them. So this is, of course, kind of what we see from Jupiter. We see this kind of outer layer of clouds. And kind of zooming out a little bit more to see the entirety, these clouds are usually in these kind of bands or stripes that are parallel to the equator. And we see that these bands tend to kind of alternate between lighter colors and darker colors. So the bands that are lighter in color we call zones, and the bands that are darker in color we call belts. The reason they're different colors is because these belts and zones are different bands of rising and sinking gas. Those lighter colored zones are rising gas, and those darker colored belts are sinking gas. And we're not 100% sure where the colorings really come from. One idea is as that gas rises in that zonal band, some of the ices start to freeze and crystallize, and you get a lot of crystals, which makes the clouds look whiter in color and lighter in color. Whereas when they start sinking, those crystals, of course, disappear, but also because it's deeper down in the atmosphere, it's not getting as much sunlight, so it might look a little bit darker because of that. But there is still some work to be done to understand exactly where the colors come from. Now, each of the belts and zones kind of represents where winds are shifting direction. So at the edge of each belt and zone, the winds switch direction. And that's why at the edges of these bands, like we're seeing right around here, you get a lot of turbulence in the clouds. You get lots of these swirls. This is also where we tend to find most of the storms, because that's where you have winds in two different directions that are colliding and intermixing and creating a lot of turbulence. And so we see lots of storms pop up in these areas. Most of the time, the storms are smaller, kind of more whitish ovals that can sometimes grow. They can combine together to form a bigger storm, and then eventually they'll dissipate out and die out. This can happen over usually years. The one exception being probably Jupiter's most notable feature, which is the Great Red Spots. So this giant storm on Jupiter, first, is huge. You can fit 2 to 3 Earths inside of the Great Red Spots. But unlike all of the other storms, it seems to be very, very stable and long-lived. Basically, as long as we have been looking at Jupiter through a telescope, we have seen the Great Red Spots, which means it's been there for over 350 years. Now, we're not quite sure why the Great Red Spot is so stable and has lasted for so long. Now, it's not completely unchanged. We have, as we've been watching it, noticed that sometimes it'll shrink a little bit, sometimes it'll grow a little bit, sometimes it seems to get a little weaker, sometimes a little stronger, so it does kind of fluctuate, but it's never completely disappeared. And again, we don't know why. We certainly don't have any experience of that here on Earth. These sorts of storms that we get are very short-lived. Guess the thing we could kind of equate it to is maybe like a hurricane. It's a little bit different because hurricanes are low pressure systems, and the Great Red Spot is a high pressure system. But we know in the case of hurricanes that as long as they stay over water, or they have that warm water, they can grow and get bigger and kind of stabilize. But as soon as they run aground, they start to lose their energy. Well, something we'll see a little bit later is Jupiter doesn't have a solid surface. It doesn't have a ground. So maybe that's part of why it's not really died. We don't know. That is one of the things we're still trying to understand. So this is just the very top layer of clouds that we can see. These clouds are primarily made of ammonia ice. So those are the clouds that we see. But deeper in the atmosphere, we think that there are two other cloud layers that sit deeper down below that ammonia ice clouds that we don't see. So we think that there is a cloud layer of ammonia hydrosulfide, and then possibly even a layer of water clouds, basically the same type of clouds that we have here on Earth. In fact, it's predicted that in those water clouds you get thunderstorms very similar to thunderstorms that we have here on Earth. In fact, we've even detected lightning coming from storm systems kind of deeper in the atmosphere. So yeah, this is Jupiter's atmosphere, and it extends down to about 3,000 kilometers below that kind of upper cloud layer that we see. Now, here's where I'm probably going to surprise a lot of people. This 3,000 kilometer layer is actually a very thin layer on Jupiter and is the only part of Jupiter where you have gaseous material, mostly hydrogen and helium. As you get deeper into Jupiter and the pressures get higher and higher, that gaseous hydrogen and helium is actually squeezed into a liquid. So just a few thousand kilometers down, you transition from gaseous hydrogen to liquid hydrogen. So the bulk of the planet is actually a liquid, not a gas. So that term gas giant that most people have heard of and used to describe Jupiter and the other outer planets, that term came about because Jupiter is primarily made of hydrogen and helium, which on Earth is a gas. So it was meant to describe more of what it was made of, but not what the state of the matter was. But that meaning kind of got lost as this term got shared and used over and over. And so now a lot of people just assume we call it a gas giant because it's made of gas. And that's not the case. So a more accurate name for this planet would probably be a liquid giant, since the bulk of it is liquid. Now, even deeper down, that liquid hydrogen is heated up so much that it strips the electrons from the atoms and it becomes liquid metallic hydrogen, which is a very, very strange substance that we don't really understand because we cannot create it in a lab. We just can't match those conditions deep within Jupiter. And then at the very center, we think that there is a solid core made of rock and other solid material. And this is again where things can be misconstrued. You'll see that it says rock and ice. Here for ice, we mean solid. We don't mean cold. You can get a solid just by squeezing anything with enough pressure. So you can have hot ice if there's enough pressure squeezing it into a solid. So it is by no means cold at the center, but the pressure is so strong that it's squeezed into a solid. So we have a core of rock and other solid, like solid ice, or solid water, solid carbon dioxide, solid ammonia, that sort of thing. Now, whether the core actually exists and how big it is another big debate in astronomy. And the reason we're not quite sure is because we have two models to explain how Jupiter might have formed. One of those models says that Jupiter should have this solid core that should be bigger than the Earth. The other model says that it probably won't have a core. And that is one of Juno's missions, is to try and take measurements of Jupiter to determine whether it does have a core and how big that core is. And that should help us constrain and better understand how exactly Jupiter formed, which will help us understand how other planets of this size form as well.
Hey, Jessica, we got a question.
Okay.
Is there likely to be a liquid surface, or is the transition from gas to liquid indistinct? Same for the transition to metallic hydrogen.
So yeah, for the transition from gaseous hydrogen to liquid, it is a very gradual process. The liquid is actually what we call a supercritical fluid, which means it's a liquid that also kind of has properties of a gas. So as you go deeper, you would just find that it gets hotter and like more humid until eventually you realize, hey, I'm actually in a liquid. There's no like ocean surface that you would splash down. It just gradually turns into a liquid. It's very strange to try and kind of understand what it's like. But the conditions here are just beyond anything that we experience here on Earth. It's probably the same for the boundary between the regular liquid hydrogen and the liquid metallic. Again, we don't really understand that material. We don't really understand the metallic hydrogen. So we're not quite sure exactly where this transition happens or how sudden it is. So that one we're a little bit more iffy on. But good questions. Okay. So I've already been talking for 22 minutes and we haven't even gotten to the rest of Jupiter. So let's transition away from Jupiter itself and start looking at some other things. Before we get to the moons, we're actually going to talk about its rings, because Jupiter does have rings. Jupiter's rings were discovered in 1979 by the Voyager 1 spacecraft. It was actually the third set of planetary rings to be discovered. Saturn's were the first, because we can see them through a telescope here on Earth, even just a small telescope. So they were the first. They're also the biggest and brightest, which is why it's kind of known for having rings. The second set of planetary rings was discovered around Uranus. And then Jupiter's were the third set, and Neptune's were the fourth. So all of the outer moons do actually have rings. So Jupiter's rings, as you can see here, are kind of in four components, we'll say. The halo, the main ring, and then there's two gossamer rings. So this is a picture of the main ring. The main ring is kind of the brightest part of Jupiter's rings, that's why it's called the main ring. It's pretty narrow, very thin, and appears to be created from debris from two of the moons that orbit within the ring. Matisse and Adrastea. I should have looked up pronunciations. But the idea is, and this is true for any ring system around any planet, the material in the rings is usually material from moons that is blasted off when the moon is hit by something, which happens pretty frequently. And so that material gets scattered around the planet and creates this ring system. And so we can see that the two moons here are set nicely within the main ring, and so it's probably material from these two moons creating it, and in fact the main ring is brightest along their orbits. So the halo, which is the inner part of the rings, is actually the thickest layer of the rings, but also very, very thin. And we think that the halo is some of the bigger particles from the main ring that have kind of migrated inward. Now, they're not big. We're talking 10, 15 microns in size, so like grains of sand. That might actually be too big. So these are likely kind of the bigger materials that have kind of migrated inward, and that's what composes the halo, whereas the main ring has a wide range of tiny, tiny little fine dust grains, all the way up to these 10 to 15 micron sized pieces, and probably some bigger kind of pebble sized pieces as well. And then we have the gossamer rings, which extend further out. And the two gossamer rings are also attributed to moons. So the Amalthea gossamer ring is attributed to debris from the moon Amalthea, and the Thebe gossamer ring is attributed to material from Thebe, just like we can see here. So this is the same idea. It's material that was ejected off due to a collision, and that material has collected around Jupiter, creating these kind of very thin, low-density rings. And so those...
We got a couple more questions.
Yeah.
Somebody asked if the rings are flat, like Saturn's.
Yes. Mostly. The halo you can see is a bit thicker, but in general, rings are very thin and very flat.
And then the other question was, well, it was a couple comments. Before we end, I urge everyone with safe solar filters to check out the sunspots. Please have safe solar filters. If you're not sure if you have one, don't do it. And then they also said smoke. The rings are like smoke. That's
a good way, since smoke is, micron kind of particles.
Right.
That's a really, really good description. There are bigger pieces in there as well, especially in the main ring, but especially the gossamer rings. That's a really good description for them. Yeah. Okay. So those are Jupiter's rings. Now we can move on with just a few minutes left. I'm going to go over 30 minutes. It's going to happen. We all knew it was going to happen. I always do that for these exploration shows. But last but not least are Jupiter's moons. So at current count, Jupiter has at least 80 moons. This is, in fact, not all 80 of them, because this picture was back before the last few were discovered. Now, most of these moons, as you can see here, have orbits that are very elongated, very eccentric. They're also tilted in random directions with respect to Jupiter, and they orbit in different directions. Some go orbiting around Jupiter in the same direction that Jupiter rotates. Some go in the opposite direction than Jupiter rotates. All of these moons with these irregular, scrambled orbits are what we call irregular or captured moons. They're likely captured asteroids that just got too close to Jupiter, and Jupiter's gravity grabbed hold of them. In fact, a lot of these are probably fragments of bigger asteroids that were broken apart during a collision, and we'll talk more about that in a minute. But of the 80 moons, 8 of them are what we call regular moons. So these are the moons that have nice, neat orbits that are nearly circular. They all orbit around Jupiter's equator, and they all orbit in the same direction that Jupiter rotates. All of these properties lead us to believe that these moons actually formed in place around Jupiter as Jupiter was forming, in kind of a mini solar system-like fashion. And so these 8 are what we call the regular or formed moons. So they formed in place, and the other 72 were either captured themselves or are fragments of a larger object that was captured and then broke apart due to a collision. So of the 8 regular moons, the 4 closest are the 4 moons that we already mentioned, the ones associated with Jupiter's rings. These are known as the inner moons, or the Amalthea group. Of course, they are Metis, Adrasta, Amalthea, and Thebe, and you can see them right here. And then the other 4, which are the outer 4 of the regular moons, are the Galilean moons, the largest moons of Jupiter, and of course the ones that Galileo discovered. So from left to right, which is also from closest to Jupiter to furthest out, we have Io, Europa, Ganymede, and Callisto. And these are pretty big moons. So we saw here, these are, 100 kilometers across, few hundred, maybe 50, maybe 10. Very, very small objects. The Galilean moons are more on par with the size of our moon or even Mercury or Mars even. So Europa and Io here are pretty close in size to our moon. Callisto is about the size of Mercury. And Ganymede is actually larger than Mercury and a little bit smaller than the planet Mars. So some very large moons here, and like I said, the largest. Now, Io and Europa are probably the two most fascinating of the Galilean moons, and I have talked about these a lot in other shows, so I don't want to go too much into it. But Io, of course, is known as the moon of volcanoes, having over 150 active volcanoes, so much so that we have images of volcanoes erupting. We even have images of lava flows flowing across the surface. It is a crazy, active, hostile little world. And then, of course, Europa, we think could have an ocean underneath its crust of ice. A huge ocean, in fact, containing possibly twice as much water as we have on the entirety of the Earth. And of course, Europa is kind of our main target for searching for life elsewhere. Because we believe life here on Earth actually started under the ocean near thermal vents, which are conditions we think are met on Europa. We think that there are thermal vents on the ocean floor. There kind of has to be to kind of transfer the heat to keep that water hot and melted and not freeze over. So yeah, we think it could be very similar conditions to where life formed here on Earth. So we want to go investigate and learn more about it. Okay, so on to the irregular moons. Now, a lot of the irregular moons are classified in groups or families. And these families are basically the moons that have very similar orbits. And the moons themselves also have very similar compositions. And that's why we think they're actually pieces of larger asteroids that got broken apart. And each of those pieces kind of kept the orbit of the original bigger object. And that's why they all have very similar orbits. And of course, they all came from the same larger object, so they would be compositionally the same. So for the irregular moons, we can kind of split them into two groups. The irregular moons that orbit in the same direction that Jupiter rotates, which is a small selection of them. It's the ones in the blue. So we have the moon Themisto. Then we have the Himalaya group, which is, again, a family of moons that are thought to be associated. And then Carpo and Voltudo. And then all the rest are irregular moons that orbit in the opposite direction, and these are all families of moons. So we have the Carmi group, the Anarchy group, and the Pasiphae group. And again, we, based off of the compositions, we're fairly certain that they were asteroids. And then just because early solar system was very violent and chaotic, and there were a lot of collisions, things hit them and they got broken apart into smaller moons. And so we have, at least 80 of them around Jupiter. Yes, Nova. Thank you. Nova has enjoyed this. All right. I think that is the end. I know that originally, I had wanted to do a lot more um, on individual moons themselves, but outside of the inner moons, which are, the ones associated with the rings, which we talked all about, and the Galilean moons, we really don't know a lot about all of those irregular moons because they are very small. And so we don't have good pictures, we don't have a lot of good kind of things to showcase. In fact, all of the pictures I saw were just little points of light. Like you don't even see like the surface or shape or anything. Sorry, my cat is yelling at me. Come here, Nova. You're gonna run away now? Come here. So, yeah, that is Jupiter and its moons. Let's see, Eli, do we have any other questions?
We got one comment that says Taurus of gas from Io, question mark.
Oh, yes. So, sorry, I had to grab Nova. She was yelling to get up on my desk. Yes, we do see that, just a little ring of ionized gas around Jupiter, which is from all of those volcanic eruptions on Io. So basically all of those gases get spewed out. Some of them are traveling fast enough to escape Io's gravity, and they end up kind of trailing along Io's orbit, creating a little ring of gas. It's called the Io Plasma Torus, I believe. Yeah. All right. I enjoy Galilean celestials. I like that mnemonic for remembering the Galilean moons. That's a really good one. All right. I feel like there was a lot that I had to cut to not have this be like 2 hours long. I mean, we spend a week, 2 weeks even, teaching Jupiter and its rings and moons in my astronomy class. And so there's a lot of other stuff to talk about. A lot of what I cut was actually how Jupiter formed, which is a really interesting topic, but I thought was maybe a little bit separate from kind of what I mainly wanted to cover today. But it made me think that maybe we should do an exploration show on the formation of the solar system, because there's some cool stuff there. So if that is something that you all are interested in, let us know, because of course we are always looking for new show topics to explore in these live streams. Yeah, that is, so just reading his question, or his comment. Yeah, that is another thing with Jupiter that I cut, was talking about its magnetic field. It does have a very, very large magnetic field, and that does interact with Io, and actually creates a current that runs from Jupiter to Io and back to Jupiter. In fact, in the UV light, you can actually see the points on Jupiter where that electrical current enters and exits the planet. It's really cool. But yeah, that is one of the topics I cut from tonight's show.
They're pretty like insane currents too. Like I feel like I remember reading like if you were to like fly your spaceship through it, probably wouldn't be super good for the electronics on board.
No, and that's one of the things, having spacecraft orbit Jupiter, they tend to stay pretty far out.
Yeah.
To stay out of that. That's why Juno's orbit It has a very eccentric orbit that for a very brief time brings it in close, and then it moves back out. So that it can get close and get some data, but as much as it's in there, it's very risky. So it immediately comes right back out. And it just does these kind of repeated dives so that it can spend the bulk of its time out of that danger area, but still get some close-up information. Yeah. Fun fact, similar tactic is being employed by the Parker Solar Probe. Although that's partly magnetic, also, you know, heat and other crazy stuff. But yeah. So I'm seeing some people wanting a show of information of the solar system. Yes. Thank you, Heidi. Yes, for anyone that is an early bird, we have a really great view of several of the planets in our morning sky right now. There's Jupiter, Saturn, Mars, and Venus, all visible in the sky just before sunrise. So go look in the kind of east-southeast just before sunrise, and you'll see those planets. And I don't think Neptune's out there yet. Neptune is still making its way around the sun. I don't think it's going to be visible until early May, but I could be wrong on that. It's been a couple weeks since I've looked at that information. Presentation on retrograde. Do you mean like the retrograde motion of the planets in our sky? Because yeah, I can definitely do that. I know I've talked about it before in some of the What's Up shows when I've talked about the planets going into or out of retrograde motion. Retrograde in general just means opposite than what it normally does. But yeah, I can try and work that in there. Absolutely. Yeah. There are some really good visuals online too, if you want to look that. But yeah, we can tie that in to somewhere. Absolutely. All right. Well, I'll give a couple more minutes for any last questions. Sorry, I realized that I had us like double on the screen because I forgot to change my OBS view, but it's fine. I'll leave a couple more minutes for any questions. In the meantime, here is our schedule for this week. So our in-person shows, Friday and Saturday are going to be, Friday we're doing Adventure to the Edge of the Universe. Our Saturday children's show is Earth, Moon, and Sun, and our Saturday general public evening show is Mars 1001. So fun stuff going on. You can find links to get tickets in the video description or on our website. Last I checked, we did still have plenty of tickets for this weekend, but we have been selling out most shows. So if you want tickets, would recommend getting them ahead of time. Yeah, and then next Wednesday, our live stream will be What's Up May, because it'll be May. I know. Kind of crazy.
I can't believe
it.
Like,
that'll be my last What's Up.
Oh my God, don't even. Yeah. For everyone, Eli is graduating next Saturday.
Yep.
Next Saturday, he's graduating. Although he is sticking around through May, so you will see him a little bit longer. But no, he's graduating and heading off to grad school, and we're all super happy and proud, but also sad.
Me too.
Eli, you got to give me a crash course on the Star Wars show. So I gotta take over it.
There are a couple of loose ends that I'm trying to that I'm going to try to tie up in May, so that I leave the planetarium in less disrepair than I created for it. And one of those is I have to finish up the Star Wars show, so I'll be sure to key you in.
Yeah, that would be good because Brayden is going to be my Star Wars guru now.
Yes, yes.
Because I need one because I don't know the show. I don't know the movies that well.
It's all good. It's all good. I'm glad to take the torch.
If you are okay sharing, there are some people asking what you're going to grad school for and where you're going.
Yeah, so I'm going to a PhD program at Iowa State University, and the program is for astrophysics.
It's gonna be our little astrophysicist.
Yep.
It'll be pretty cool.
I feel like the proud Planetarium mom.
Yeah, absolutely.
My little Planetarium kids are growing up and graduating and going off to do awesome things. And you can bet I'm going to drag him back here as often as I can.
Oh, yeah. I'll be back quite a bit.
All right. I think we should do something special for your last live stream.
Yeah,
I agree.
Which one is that going to be? Do we have that scheduled yet?
I did. I was going to finally do the Exploring Early Astronomy. Oh, okay. Because I had to cancel that one because I didn't have time to finish it, but now I kind of want to not do that and do something different.
Yeah.
Do you want to do one last show?
Yeah, I'll do that.
Which one? And do you want to leave off on Star Wars?
I could do that. I'm trying to think.
How about think about it, let me know, and we'll update the calendars and everything.
Yeah. All right. Sounds good.
I think that's a good idea. And then I can silently cry in the background. Last show, shoot down the Death Star.
It's actually funny. Not too long ago, I have an iPhone, and I took a picture of the moon, and like something about the iPhone's resolution, and like craters on the moon. I took a picture of it, and it looked like strikingly close to the Death Star. Like it was actually kind of creepy. So I'll include that in.
Yeah.
In final show.
Yeah. All right. I think we pretty much wrapped up on questions and stuff. Thank you everyone so much for joining us. I will get our schedule updated with whatever show Eli wants to finish up with. Yeah, otherwise, everything's on our social media and our website. Lots of fun stuff going on. We are planning on doing telescope viewing for the lunar eclipse in May. I will have more information on that at the What's Up show next week. So we will be doing eyepiece viewing and hopefully have a live stream on Facebook as well. But yeah, I'll have more on that next week. All right, we'll wrap up there. Have a wonderful rest of your evening, everyone, and we hope to see you again next time. Bye.